We have the integral ln x squared dx, and this might not look like an integration by parts problem initially, but after we do a little bit of work with u sub, it will certainly turn out that way. So what we'll do is we'll say u equals ln of x. The derivative of u in that case is 1 over x dx, and we need to get just dx on its own because in our original integrand we don't have 1 over x dx, we just have dx. So what we'll do is we'll multiply this x over, we'll get x du equals dx, and the problem now is we've got x and u in the same term, and that doesn't jive very well. So what we can do is bring down our original u that we built, and we can say u equals ln of x. In this case it's a natural log, so it has base e, and we can go around and we can change this using log properties to be e to the u equals x. So now we have solved for x, and we can replace this here. We can say e to the u du now equals dx. So now if we go back to our original problem and we go ahead and fill this in for our u sub, we can say it's now the integral of e to the u times u squared du. And now we have a product, and because we have a product, that's indicative that we have an integration by parts. So what we can do now is we can let w equal u squared, and then of course the derivative of w will become 2u, and then dv in our integration by parts will be e to the u, and of course v here, when we integrate, will be e to the u as well. So now we can go across and then back down over to perform our integration by parts, and we can rewrite all of this. We can say u squared e to the u minus the integral, we'll put a 2 out front from here, times u e to the u du. And we've got another pair here, which is a product, so we can go ahead and let w, yet again, equal u, and then the derivative of w in this case is just the derivative of u. And then we've got another dv, which is again e to the u, and when we integrate that, we also get e to the u. Now, because it's integration by parts a second time, we'll go across the top and then down and over again. So we can rewrite all of this. We have u squared eu minus 2 times, now we have u times e to the u, minus the integral of e to the u du. Now we know the integral of e to the u du, we've done it a couple times already here. We can go ahead and cross this out and just write e to the u. And so now we're left with u squared e to the u minus 2u e to the u, plus now, because we have a negative and another negative, 2 e to the u. And this is an indefinite integral. We're not dealing with any limits, so we have to add a constant at the end. The only thing that I would do now to polish this up is pull all of these e to the u out. We'll do e to the u times u squared minus 2u plus 2, and then plus that constant at the end. But we're not done. The last thing that we have to do to finish this problem, as we've noticed that we're still working with a problem in terms of u, is we have to come all the way back up here and pop it in terms of x by plugging in our original u again. So originally we did a u sub where we substituted for ln of x. So here we just do e to ln of x times ln of x squared minus 2 times ln of x plus 2, close the brackets, and add a constant. Here, using log properties, we know that e to the natural log of x is just x times ln x squared minus 2 ln x plus 2. And this is our final answer. If you have any questions, or if you'd like me to tackle any other calculus or physics problems, let me know in the comments below. Otherwise, I hope that you found this helpful.